In this example of dynamic programming, I'm going to use the famous rod cutting problem to illustrate a similar problem in a different context. So let's have a look at that example. So the rod cutting problem is a problem that tries to find the maximum revenue you can get by cutting a rod or resource of a length n, which can be cut into pieces and sold in pieces according to a price table corresponding to the different lengths. Now, there is no cost to cut the resource. So the table might look like something like this. We have a resource of length n. If we cut 1 unit off it, we can earn a price 1. If we cut a length of 2, we can earn price 2. If we leave it uncut, we can get n, price n for the resource. So let's put that in a different context with the AirTasker. So the AirTasker is looking for jobs on AirTasker app, and the goal is to maximize their revenue, and they're going to allocate a certain portion of their time in hours to try and get some jobs to do that. So the AirTasker wants to maximize their earnings for working H hours, where different hour lengths are charged at different prices. So if we set this problem up, it's very similar to the rod cutting problem. We're maximizing earnings for a resource of a fixed length. In this case, for the AirTaskers, it's their working hours of H hours. So say this was the price table that they're working with. They're going to allocate, they're going to get charged $10 for 1 hour jobs. For 2 hour jobs, they're going to charge $15. For 3 hour jobs, they're going to charge $25. 4 hours, $60. 5 hours, $70. 6 hour jobs, $110. 7 hour jobs, $180. And 8 hour jobs, the whole allocation is $200, I guess. So let's set up a table to do this. So this can be the revenue table, and we can initialize that, assuming we are selling 8 hours of our time on AirTasker. We can set up indexes for the positions of that revenue array, including a 0 index. So obviously we want to run dynamic programming to work out the maximum earnings we can make. So to begin with, let's just initialize the array with what we have here. Well, obviously for 0 hours, we can earn 0 amount of money. For 1 hour of our time, we can earn $10. And if we just multiply each hour allocation and just take 1 hour jobs, we can make $20 for 2 hours, $30 for 3 hours, $40 for 4, $50, $60, $70, and $80 to sell 8 hours of our time in 1 hour chunks. So let's see if we can improve this initialization. So we've just initialized that. Let's see if we can improve that by using dynamic programming. So we're doing that from the bottom up. So we're going to start at 1 hour. Obviously, we can't do better than $10, so we're going to stick with that one. But when we get to $2, we can go back in time, either 1 hour and add a 1 hour job, or we can go back in time 2 hours and add a 2 hour job. So let's have a look and see what we can do. So if we go back 1 hour, we can add another 1 hour job. That's 10 plus 10, which is 20, which we already have, no improvement. So we don't change. If we go back 2 hours in time and take a 2 hour job, we make $15, which is not an improvement on 20. So now we've maximized the earnings for 2 hours. Let's do the same for 3 hours. For 3 hours, we can go back in time 1 hour, 2 hours, or 3 hours, and see if we can do better. So if we go back in time 1 hour, that's $20 plus a 10-hour job, which is what we have here, $30. So we've done that. Let's go back 2 hours in time. Let's take a 2 hour job. That's going to be 10 plus 15, which is 25. That's no better. So let's go back 3 hours time and take a 3 hour job, which is $25, which is no better. So let's leave that unchanged. So we have the maximum earnings there for $3. Let's do the same now for 4 hours allocation. So for 4 hours, we can go back 1 hour, take a 1 hour job, 2 hours, take a 2 hour job, 3 hours, take a 3 hour job, or 4 hours and take a 4 hour job. Getting a bit messy now. So let's go back 1 hour to $30 and add a 1 hour job, which gives $40, no difference. Back 2 hours we had 20 there. Add a 2 hour job, which is 20 plus 15, that's 35, no improvement. Go back 4 hours and add 1 4 hour job, and that's going to be 0 plus 60, which is an improvement. So we cross that one out, so we've got our $60 there. So that was going back 4 hours and taking a 4 hour job. So let's have a look. The same thing we can do for the 5 hours now. So we're moving up, building the solution from the bottom up. So for 5 hours, we can go back 1 hour in time, 2 hours in time, 3 hours in time, 4 hours in time, or 5 hours in time. If we go back 1 hour in time, we can add a $10 job, 1 hour job to the $60, which will give us 60 plus 10, which is 70. That's an improvement on this one. So we take that. So, or we can go back 2 hours in time, which was $30, and add a 2 hour job to that, which is 30 plus 15. That's 45. That's not an improvement. We can go back 3 hours and add a 2 hour job, 3 hour job, which will be 2 hours plus 3 hours, which is 20 plus 25, that's 45. That's not an improvement. Or we can go back 5 hours and add a 4 hour job to $10, which is going to be 10 plus 60, which is 70, which is not an improvement. We already have that. Or we can go back 5 hours and take a 5 hour job, which is 70, which we already have. So now we have the maximum for 1, 2, 3, 4, 5, and 6. So you can see we just need to repeat this all the way up to 8 hours. So let's have a go at 6. This does get a bit tedious, this tracing, but if you want to, you can still stick with it or fast forward. So now we're going to go back in time, all the different amounts, 1, 2, 3, 4, and 5. And of course 6. Getting messy here. So if we go back 1 hour in time, we can take a 1 hour job, 70 plus 10, that's 80. That's an improvement there. We can go back 2 hours in time and take a 2 hour job, which is 60 plus 15, that's 75. That's not an improvement. Go back 3 hours, take a 3 hour job, 30 plus 25 is 55. That's not an improvement. Go back 4 hours and take a 4 hour job, that's 20 plus 60, which is 80. That's not an improvement. Or go back 5 hours and take a 5 hour job, which will be 10 plus 70, which is 80. We'll go back 6 hours and take 1 6 hour job, which is going to be 110. So now we have the maximum for 6 hours. So let's repeat for 7. Go back 1 hour, add a 1 hour job to 110. That's going to be 120, which is a much better value than 70. Go back 2 hours, add a 2 hour job to 70, which is 70 plus 15. That's 85, no improvement. Go back 3 hours to 4 hours, 60 plus a 3 hour job, 60 plus 25, that's 85, that's no improvement. Back 4 hours to 3 hours, 30 plus a 4 hour job is 90, not an improvement. Back 5, $20 plus a 5 hour job is 20 plus 70, that's $90. That's not an improvement. Go back 6, to 1 and take a 6 hour job. That's $10 plus 110, which is 120, which is what we already have. We'll go back 7 hours and take a 7 hour job, which is 180, which is much better. Okay, you can see this is getting quite tedious. Let's just do it one more time for 8 hours and we're nearly done. Go back 1 hour. We've got $180 at a $10 job 10-hour, 1-hour job to that, we've got 190, much better. Go back 2 hours in time to 110, add a 15 2-hour job, that's 125, that's not better. Go back 3 hours in time to 5 hours, add a 3-hour job to 70, that's 70 plus 25, 95. Go back 4 hours in time to $60 and add a 4-hour job, 60 plus 60 is 120, not an improvement. Go back 5 hours in time to 3 hours, which we had $30, and add a $70 5-hour job to that. That's going to be $100, which is not an improvement. Go back 6 hours in time, which is $20. Add a 6-hour job, that's 110, which makes 120 plus 110 is 130, not an improvement. Go back 7 hours in time, we have $10. Add a 7-hour job, that's 190. We already have that. Go back 8 hours in time, we go back to 0, add 1 8-hour job, that's $200, and that is much better. So now we have built up this table, and we now have the dynamic programming. We have done the equivalent, all that toing and fromming tracing. We went from I equals 1 to 8, and then for every value from j equals 1 to that I value, we took the maximum value of the revenue that we could by comparing the revenue currently in the table at that index with the revenue going back by those number of hours and adding the price for those number of hours to get our result. So that is the Airtasker problem for maximizing the earnings for working H hours in the style of the rod cutting problem. Thank you.